Okay, in the last pair of videos, we modeled our frustum in both SketchUp and Fusion using the same set of dimensions, followed a very similar modeling approach, and produced basically the same result. Awesome. That initial iteration also helped us identify a couple of opportunities for improvement. So it makes sense to iterate on our design by exploring different dimensions that produce a pattern that is functional, aesthetically pleasing, and balanced, while still adhering to our requirements to be easy and efficient to fabricate with tooling that is readily available. More specifically, I want to fabricate a clean frustum pattern with hidden miter joinery that's easy to set up on the track saw or uses off-the-shelf V-bits for the CNC. Now, one way to iterate on our design is by brute force, literally recreating the model each time with different dimensions. Let's do this in SketchUp. All right, here we are in SketchUp, and we've got our frustum modeled. It's 14 inches tall. It has a 31.7 degree side angle, and it's 1 inch thick, swept around a 28 by 28 inch top. And it looks fine. It would certainly be functional for a water feature or a planter. But like we mentioned, as a fire bowl, the proportions don't look quite right. It looks like something that would tip easy. And it'd be nice to iterate over our design, make some changes to the different dimensions, and compare those to see if we can land on something that's aesthetically pleasing and looks more balanced and more functional. In SketchUp, there really is no parametric way to do that, so I'm just gonna do it with brute force. So first, let me hang on to the one that we have. And so I'll just select that, and I'm just gonna group everything. And then we'll just kind of move that out of the way, just out of the way of where we're gonna draw. Okay, and I think that what I wanna do first is I want to make the frustum a little bit shorter. I think that's gonna help with the proportions. Right now it's 14 inches. So let's try 12 and see what that does. So I'll draw myself a guide, and we'll keep that same 1 inch dimension here. And then I'll just draw a couple of line segments real quick. And I'm gonna do this pretty quick. I'm not expecting anyone to follow along. The point obviously is to show what it takes to do this by brute force in SketchUp, and then compare that to the parametric way. So if you're trying to follow along, don't worry about it. I mean, if you're fast enough to follow along, fantastic, but don't try and follow along for this. That's not the point of this particular exercise. And all I need to do is get rid of that segment there, and that will open up that part of the profile that we'll then use the same way that we did before as part of the follow me function. Okay, so let me look at this from an ISO view and zoom out just a little bit. Like before, I'm going to copy that over to the origin here, and then I'll select the path. I'll go ahead and select follow me. And now, if we look at these from the front, right, and we should have our same angles, right? Nothing changes, it's just shorter, still 62.3 degrees, but that looks a little bit better to me. It looks a little bit more balanced, the one on the left that's shorter than the one on right that looks a little bit too tall and top heavy. So as we mentioned, ideally we're coming in at 14 to 16 inches tall for a fire bowl or fire pit. We don't want to be much taller than that. Shorter is okay, but ideally we're at 14 to 16 inches tall. This one's 12 inches tall, a little bit short, but again, proportionally looks better to me. Now, another way that we can augment our design here, let me go ahead and group this and get it out of the way as well, move these guys over, is instead of making it shorter, we can keep it the same height, but make the opening bigger. So if we move it from 28 to something like 32 or maybe even 36, I think the proportions will come better in line as well. So let's try doing that. So just like before, we'll draw another rectangle from the origin. So I use the rectangle tool here. And in this case, let's start with 32, just see where that gets us. So 32 by 32. And I'll need to get rid of this face. I don't need it. And I want to move that up from the origin just a little bit. So I'll move it over this. And let's go ahead and return our profile here back to what it was before, that 14 inch height. So I'll just move this line segment, close this one back off, and now we've got that, and let's go through the exercise again, right? So I will ISO view here, let's copy that over to the origin, select our new path, the 32 by 32 path, select this. So, and now let's look at that from the front, zoom extents. That also looks better to me than this original one, but it is bigger. right? So it is 32 by 32 rather than being 28 by 28. And maybe 28 by 28 was all of the real estate that we were given, right? So, you know, that's kind of a consideration as well. But again, this one looks much more balanced than this one does. For the same height, right? So 32 by 32, 14 inches tall, 28 by 28, 12 inches tall, 28 by 28, 14 inches tall. Another thing that we might want to do is play around with the different side angles. So we've got this kind of dramatic side angle here. Remember, we recognized a different side angle that was much steeper, 24.5. That also might be helpful. So let's go through the exercise and model that. So same thing here. I'll go ahead and let me annotate this guy right here. I should have annotated the heights as well. That would have been helpful, but I think we'll be able to follow them. So 62.3, select all that, select this, group them together, and let's move all of this stuff out of the way. And I'm just moving right now. Tagging will actually be a better way to do this. Let's go ahead and move that. I don't know. All right, now let's change the side profile to that 24.5. So let me look at the model from the right-hand side. We'll zoom in on this right here. And let me just select all of this, right? And we will group that. And let's move it out of the way as well. So 20 inches, I guess. Now, if you recall, the way we did this was we drew first a helpful bounding box, so 14 by 14. So we'll do that again. And then this over, we drew our guide here. So that now we want to be 24.5. That gives us that whole number blade tilt of 40 degrees. And this is going to be a much steeper side angle. And let me just go ahead and annotate these things real quick. So this will be, again, 14 inches tall. And this side angle will be 24, and its complement will be, what is that? 65.5, is that right? Draw our line to represent the side. And we'll go ahead and select this and this. We'll do our thickness, 1 inch. And there's our alternative profile with a much steeper side angle. Let's play around with that. So remember, we want to move this whole mess over so that we can get it out of the way of the origin. So let me just take the move tool, grab this corner and move it out of the way just a little. And we will copy move this new profile. And why don't we start with our 28 by 28, follow me, new profile, and then let's look at that from the front. And that also looks better to me. So this is 28 by 28. It's also 14 inches tall, so just like our original, but a much steeper side angle. Looks more balanced to me than does this one over here, right? Again, this one is just giving me really fear of tipping over and causing a big old problem. Whereas this one over here just looks more balanced and stable. And it's the same top height, or it's the same top dimension, 28, 28. It's the same height, 14 by 14, just a steeper siding. So that, let's go ahead and annotate this guy here and select that. And I'm not doing this on purpose, but this is getting tedious in a hurry in SketchUp, doing all of this manual mumbo jumbo. Select these guys, move all this stuff over, 2 over, 36 over. All right, let's try it one more time, but with that larger top open. And mind you, all we've done so far is tried a couple of different heights and 2 different side angles. We haven't played with the thickness of the frustum at all. We haven't changed much in terms of the proportions. Everything, it's been pretty rudimentary in the changes we've made so far, and it's getting tedious. Nevertheless, one more, let's try it one more time. We will, again, copy our profile over, center, select our bigger opening, get it from the front. So much more balanced, but that one's almost a little too boxy. So it sort of depends on the situation. I would imagine if that were a much bigger profile, like right now it's 32 by 32, but if we got to 36 or 48, it would look way too boxy, whereas something like this would actually look more pleasing. But again, we'd have to run through some more iterations to do that. You get the kind of idea. Now, we could do some things here to organize a little bit. So one of the things we could do is tag things. So as an example, I could tag all of these. Let me go ahead and go to tags. We're going to need to create a new tag for this. We'll call this, this was the 31.7. Okay, I've got a new tag defined, and then I'll just enter the info, tag all of these with that. And the benefit in doing that is I can now use tags to show and to hide and show what's in my model. So it'll kind of, you can have a bunch of stuff in there, but sort of unclutter it. We'll do the same thing with these two new ones that we just drew. So let me annotate this real quick, select all that, plus that, and we'll tag those two. Let's create a new tag, and that is our 24.5 degree set. Entity info, tag those, okay. And then if we zoom out, right, we can, I guess it would make sense to tag this as well. Let's tag this whole mess, including this, group that, tag that, show and hide that stuff. And then the same thing with this one. Entity info, that one is going to be our 31.7, right? And so we can do the same. All right, so there you go. I didn't really create that many permutations, 5 total. One was the existing one. And then there were 2 permutations of that with the same side angle. One was shorter, one was the same height, but a bigger top. And then I created 2 more with the steeper side angle. Both of those the same height, one with a 28 by 28, the other with a 32 by 32. Now, as you can see, this can get tedious in a hurry. We could either save each of those permutations as a separate design file or go through some sort of complex tagging approach to keep things organized. Now, adopting an approach like this at scale would be an absolute nightmare in my opinion. I could do the same in Fusion, but luckily there's a much better way. So in this video, we're going to introduce a concept called parametric modeling, which, as I've started to ramp up on Fusion, has completely changed my perspective for the better on using it. Now, if you're not familiar with it, parametric modeling is a design approach that enables you to create 3D models based on a set of parameters or variables. These parameters can include dimensions, angles, distances, and other geometric properties that drive the shape and size of your model. So for our exercise here, I've already mentioned them: height, side angle, top opening, thickness. They're all parameters that drive the shape and size of our frustum. Now, the key feature of parametric modeling is that these parameters are interrelated, meaning that if you change one parameter, the entire model automatically updates to reflect that change. Hold that thought. It's pretty mind-blowing when you see it in action. Now, unfortunately, SketchUp does not provide functionality to support parametric modeling natively. It just isn't built that way. Now, to be fair, there are some advanced plugins available for SketchUp that provide some parametric modeling capabilities, and kudos to the developers of those plugins. I can only imagine them. But if you're looking to really take CAD seriously and incorporate it into the standard workflow of your business, I'd be pretty hesitant to adopt a solution that was heavily reliant on open source plugins. There's nothing wrong with open source, but you have to go in eyes wide open and be honest about things like support, compatibility, feature parity, ongoing updates, and stability that's reasonable to expect. The last I checked, the most popular plugin for this functionality, named, shocker, parametric modeling, was last updated in 2021. Now that's over 3 years ago, and it's never reached a status beyond an initial point release. So again, eyes wide open. All right, so now let's model our frustum the parametric way in Fusion. Now we could do this in any order, but first let's go ahead and create a sketch, and we'll use the YZ plane modeling from the right-hand side like we did before. And before we do anything else, let's now define several parameters. There's a few different ways I can get to it, but one way is under the Modify menu, and you'll see this item here, Change Parameters. You'll notice that we can now add user-defined parameters by simply clicking the plus sign, and the first one we'll add is height. You'll notice that it defaults to a dimension in inches, which is based on my default unit of measure, and that's exactly what we want. Now, for each variable, you can enter an expression that Fusion will evaluate for the value, but hold that thought. We'll come back to that. Keeping it simple for now, we'll just type in 14, which is the same height we used before when we modeled our first iteration. Okay, next, even though we're using the same value, let's actually add 2 for the top dimension, width, and length. For width, let's go ahead and enter 28 inches, just like our initial model. And for length, we'll get a little fancy and enter an expression of width. Notice how it knows the value of that variable. This is the simplest expression you can enter, where the value of one variable is exactly that of another. But again, baby steps. Now, let's see this work. Let's change the width. Notice how length changes as well. Pretty cool. For now, they will be the same, but keep in mind, we can change them independently, and we'll come back to that later. All right, next, let's define a variable for our star of the show, the side angle. I'll go ahead and type in side angle, and every variable name needs to be one word, no spaces. In general, I like to use all lowercase for naming variables, but when there are multiple words like side angle, I'll use what's called camel case. So start in lowercase, and then every subsequent word will start with a capital letter. It just helps make a variable easier to read. Also keep in mind that we are defining an angle, so we need to change the unit here from inches to degrees. And as you look through this, notice how there are different types of units and different units of measure within those types. So you can use whatever's most appropriate to you, but remember, it's important that we use a unit here, in this case, degrees, to represent an angle, not distance. Okay, just like before, we'll use a side angle of 31.7 degrees to start. All right, let's get a little tricky. Let's add another variable called side angle complement. As you may recall, the side angle from our compound angle calculator represents the angle from the vertical, but in Fusion, a line's angle is represented from the horizontal. And so we need to use the complement of the side angle to properly model that. Now, we could just enter the value of that complement in our side angle variable, but for me, at least, this makes things so much easier because I can represent the side angle exactly as it's specified by the calculator, and then have a variable in here whose expression does all the work and computes the appropriate complementary side angle for me. So again, the unit for this will be in degrees, and the expression in this case will be 90 minus side angle. That's the expression that will evaluate to the complementary angle of that side angle. And notice how it accurately represents 58.3 as the value of that expression given the current side angle of 31.7. All right, let's add one final one to represent the thickness of our frustum. Again, this one is not super important for our current exercise, but to be thorough and accurate, it makes a lot of sense to model the thickness of the frustum as a parameter as well. Downstream, this will allow us to do all kinds of things like automatically calculate the volume, which will then help us calculate batch size, weight, etc. So we'll define thickness, and it's also appropriate to represent in inches, and we'll simply start with 1 inch for our thickness. All right, now that we have those parameters defined, let's go ahead and actually use those in our sketches. We've already started to sketch here. Let's now model the frustum profile. Just like before, we'll start by drawing ourselves a helper bounding box that represent the height of the frustum. And we'll use a 2-point rectangle for that. Click in the origin, drag out, but instead of entering values directly, notice as I start to type in the word height, Fusion knows that I'm referring to and wanting to use that variable. Go ahead and hit enter, and then I can tab over to the other input field, enter the same for that, hit enter, and then hit enter again to complete the rectangle, and bang, there's our 2-point rectangle that happens to be 14 by 14 in dimensions based on the current value of the height parameter. Next, let's go ahead and identify that as a construction line, just like we did before. Double click, and then click on the construction button on the right-hand side. All right, next, let's go ahead and draw a line to represent the side angle of our frustum. And just like before, start at the origin, go out along the horizontal axis, and then rotate down. And remember, we are currently in the length field, so we need to tab out of that to enter the side angle. And here's where we can use that special variable we defined, side angle complement. Go ahead and enter there, and bang, there we go. Our line is now constrained to that value, which happens to be the complement of the 31.7 degree side angle, which evaluates to 58.3 degrees. Just like before, we'll now drag that out till we intersect the bottom construction line and finish that line. Next, we'll draw another line segment from there over to the bottom right corner of our construction box, and that represents the outside of our frustum profile. All right, next, let's model the thickness. And just like before, we'll use the offset tool for this. Click on the line segment for our side angle that we just modeled. And just like before, we can drag one direction or the other. And as you can probably guess, we'll use our thickness variable here. But remember, Fusion uses a positive and negative number to represent the direction of the offset. So in this case, we'll need to enter negative thickness to properly represent that offset. Hit enter, and there you go. There's our thickness, in this case, a 1-inch offset. All right, just like before, we need to finish off our profile to create a closed face by drawing the short line segments at the top and bottom of our model. And just like before, if we've done all of that correctly, we'll get that visual confirmation that we've closed off the face. It'll turn blue inside there, and there you go. We now have a profile for our frustum modeled the parametric way. All right, before going any further, let's test out and put those parameters to work. As I mentioned before, there's a number of different ways to get to the change parameters dialog. In this case, I'll type S to bring up the search box. You can do this anywhere in Fusion to quickly get to functions and capabilities. Next, I'll type in change, and then you'll notice the list lists a bunch of different options or functions, and I can select change parameters from the list of results. That will open the parameters dialog. Now let's make some changes. All right, first, we'll change the height. Let's go ahead and change it to 16. Next, let's change it to 12. And notice how the model reflects those changes. Same with the thickness. Let's go ahead and try 1.5 inches. Let's try 3 inches, a little bit more obvious. And now let's change that side angle. And remember, we have several side angles that we know from our calculator dictate whole number blade tilt angle. So another of those is 33.8 degrees. So let's go ahead and enter that. And it's actually easy to miss, but it's so awesome. Notice how Fusion is computing the side angle complement. So 90 minus 33.8 is 56.2. And then using that for the value of the side angle in the model. Try it again. This time, let's use that other side angle, 24.5 degrees, and bam, pretty freaking cool what's going on here, and we're just getting started. All right, let's go ahead and return those values to match those of the initial version of our model. So 14 inches for the height, 1 inch for the thickness, and 31.7 degrees for the side angle. Go ahead and close that out, and let's finish the sketch, and then we can rename it something like Parametric Frustum Profile. And once we've got that, let's go ahead and move on to model the frustum top for the path to sweep that profile along. All right, now that we have the profile, let's model the top of the frustum for the path. And you can probably guess how this is going to go. Let's first create a sketch, and like last time, select the XY plane. Next, we'll create a 2-point rectangle to represent the top of our frustum, and we'll start at the origin. And just like in the profile example, we'll use our parameters to represent the length and the width of the frustum, both of which happen to be the same at this point because one is simply referencing the other. Again, notice how it evaluates those to 28 inches. Couldn't be easier. At this point, we're done with this sketch, and we'll click Finish Sketch. And then let's go ahead and rename this sketch something like Parametric Frustum Path. All right, now that we have the profile and the path, we can use the sweep command to create the frustum body. Just like before, select Sweep from the Create menu, select the profile first, then select the path. There's our frustum. Now let's have some fun. We'll go ahead and bring up the Change Parameters dialog again by typing S, searching for Change, and then selecting Change Parameters from the list. And now, let's start changing some values. First, let's go ahead and change the height from 14 to 16, and then to 12. We can also change the width and the length to 32. And for fun, we'll change the thickness from 1.5 to 3 inches to really be able to see it. And of course, the big one, let's change that side angle. First, we'll change it from 31.7 to 33.8. And now let's change it to 24.5. Pretty friggin' cool. This is the kind of capability that's winning me over. Now, taking this a step further, while we are modeling the pattern for tooling, I can also get some information about this object through its properties. I went ahead and added the custom material to Fusion to loosely represent GFRC, which I believe is approximately 132 pounds per cubic foot. So I can apply that material to this body. And then when I look at the properties, it's in ounces and cubic inches. So let's convert those. We'll do a quick conversion. And those give me some incredibly useful look ahead information to use in my design process. All right, I hope you found that helpful. It was definitely an eye-opener for me as I started to dig into Fusion, and again, has completely changed my perspective on using it. As I've mentioned, I'm not much of a designer. I know what looks good and what doesn't when I see it, but I don't necessarily know it ahead of time. With parametric modeling and the ability to rapidly iterate, Fusion is actually making me a better designer. It's helping me create better, more aesthetically pleasing, functional elements, while also accelerating my process, cutting down on unnecessary errors, and being most efficient with materials and resources in the shop. This is how you multiply your time. In the next video, we'll do just that. We'll take our design and start to apply CAM concepts for things like cut lists and tool paths to help accelerate fabrication. I'll see you in the next one.